Hello, this is Mr. Huff, and I want to talk to you about the Semester 2 Final Exam Study Guide. Again, we are encouraging you to use your notebook as a tool for review. Go through these questions and draw diagrams, write down definitions, make tables and lists of the different characteristics that we've seen. For momentum, we're looking at Newton's first law. So this is going to be Newton's third law, the law of equal and opposite reaction forces. It's the same thing in law of conservation of momentum. You can't lose the total product of mass and velocity. It has to be the same. If it's not the same, it's escaping somewhere. You need to compare elastic and inelastic collisions. You need to be thinking about which one conserves kinetic energy and which one loses kinetic energy. For thermodynamics, you need to define temperature. You need to define latent heat. You should be thinking about things that are changing phase. And specific heat capacity, remember the unit tells you what it is. It's the amount of heat required to change the temperature of a certain mass by 1 degree Celsius or Kelvin. Define the methods of heat transfer and give examples of each. You should be thinking about conduction, convection, radiation, and contact, that sort of thing. Describe what happens to water at 0 degrees and 100 degrees. We see phase changes where we're putting energy into or taking energy out of the system without a change in phase or temperature for a while. Eventually, water will go from a liquid to a solid at 0 degrees, and it will go from a liquid to a gas at 100 degrees. Define entropy and include an example. My favorite example is your room. It goes from a state of order to disorder. Number 5, compare the characteristics of materials that have a high and low specific heat capacity. Things that tend to have a high specific heat capacity also tend to be insulators. They don't like to change temperature very easily. Low specific heat capacity items tend to have high conductivity. It's easy for them to release energy or energy to pass through them. Number 6, what conditions must be met for heat to transfer from one body to another? They cannot be in equilibrium. They have to be different temperatures. Remember, heat always goes from hot to cold, never the other direction. That's why it takes work to make air conditioners work. Identify conductors and insulators. You've been doing this before. If you're not sure how to do this, come talk to Mr. Huff. The first law of thermodynamics is the same as another law. What is it? This is the law of conservation of energy. Q equals mc delta T. Look over your notes. You should have some examples for this calculation. For the quantity of heat, it's equal to the product of the mass times the specific heat capacity multiplied by the change in temperature. Find some examples and look at those. For wave, sound, and light, we've been working on this, so it should be pretty fresh on your mind. As a pendulum swings, describe what happens to kinetic and potential energy. So at the highest points, the pendulum bob comes to a stop, and it's above the ground, so it has potential energy. As it swings back to equilibrium, it reaches its maximum kinetic energy at equilibrium, and then as it passes equilibrium, it starts trading the kinetic energy for potential energy. List electromagnetic waves in order by frequency, energy, wavelength. Include the colors. You need to know the acronym ROY, G, BIF, red, orange, yellow, green, blue, indigo, and violet. On the test, you will be provided a reference table for the electromagnetic spectrum. Use sound to determine distances using velocity is equal to distance divided by time. So if you know the time it takes for something to echo and that sound moves at 340 meters per second, you can calculate the distance. Compare transverse and longitudinal waves. I would suggest building a table. Remember, one of these is, it's all related to how the movement of the medium and the direction of energy transfer. Transverse, the movement of the medium is perpendicular to the direction of energy. And in a longitudinal wave, the movement of the medium is parallel to the movement of the energy. List examples of transverse and longitudinal waves. So if you're making a jump rope move, that's a transverse wave. Longitudinal waves are things like sound waves, like the ones coming from my mouth to this microphone through our connection here on YouTube to your ears. What is the unit used to measure the perceived loudness of sound? That is a decibel. So remember, every time you go up by 10 dB, 10 decibels, the sound sounds twice as loud. Number 11, how many colors can be formed from the 3 primary light colors? You should have discovered that all of them can be made from these 3 colors. This is why televisions and even your cell phone screen only have red, green, and blue light. How many primary colors? How are primary colors and pigment colors related? This reference table will also be provided to you, but you should recognize that the primary of one color theory results in the secondary colors of the other color theory. Number 13, as a wave moves from one medium to another, the characteristics which change and which remain constant: velocity, wavelength, and frequency. So you need to recognize this. Velocity changes, frequency stays the same, so in order to achieve that velocity change, the wavelength also has to change, but the frequency remains constant. When light passes through a prism, which color is bent most and which is bent the least? I think you need to find some pictures. For work, energy, and power, be able to determine work being done or not in various motions like lifting a piano or carrying a book. Remember that for work to be done, the force applied and the distance or the displacement have to be going the same direction. So if you're carrying a book in the palm of your hands and walking around the room, the force from your hands is going up and down, and you're carrying it around the room left and right, so they're perpendicular, no work is being done. Define mechanical energy and describe a system that demonstrates mechanical energy. Mechanical energy is simply the sum of potential and kinetic energy in a system. They can trade places, but you can't increase or decrease that. You can lose some energy from the system in the form of heat through friction. Remember how to use the formula: work is force times distance. That's not very tough. And then review your notes for charges and electricity. You need to recognize which charges attract or repel and what factors affect electrical force. You need to look at the formula that talks about the charges and the force between those charges. And there's also distance or radius related to that formula. If you kind of consider that formula, it will give you the answers for these questions that relate to electrical forces. Determine equivalent resistance of a series and parallel circuits. Remember that in a series, you simply add up the resistors. In a parallel circuit, it is the sum of the reciprocals of the resistances. What makes an atom into an ion? This should have been related to our discussion about charges. Don't know if we were clear about it, so let's talk about it right now. When an atom loses or gains an electron, it becomes an ion. So if it loses an electron, it's lost a negative charge, giving it a net positive charge. If it gains an electron, then it has an extra negative charge, so it would become a negative ion. You need to compare and contrast electrical force and gravitational force. I think we did this earlier this year. Just real quick, we'll touch on some highlights. Electrical force is immensely more strong. Is that a proper word? It's immensely stronger than gravitational force. Gravitational forces are only attractive, and electrical forces are repulsive and attractive. You need to analyze electric field diagrams. So remember, we made the little diagrams with the particle in the middle and the arrows pointing either toward the negative or away from the positive. If you want to see some of these field lines, physicsclassroom.com has an electric field line interactive so that you can stack up charges and see how the field lines interact. And where does the battery get its energy? It's a chemical energy that batteries use to make electricity. Then number 9, review circuits to predict behavior if a part is added or removed. So think about circuit analysis that we did when you built your houses. If you took a light out, or if you added a light, or if you cut certain wires, you have to predict what would happen. And last but not least, be able to use these two calculations. Voltage is equal to current times resistance. This is Ohm's law. And power is equal to current times voltage. And there's a couple of other forms that we have in your notes, but I think I keep the exam to just that form. So I hope this helps you. If you have any questions, be sure to stop by and ask, or ask before the exam if something is unclear, because if you have questions, everybody probably has questions. This has been Mr. Huck.